Hello, I'm Mike Mraz.
I'm Jordan.
So for the project, I was kind of brainstorming with Jordan about designing a small canning line for the brewery because we needed something small to can some of our beers. Obviously with COVID, we had an issue with trying to get enough packaged beer because
Trying to fill off by hand and doing it from the tap was really slow, so we kind of wanted something smaller than like an industrial scale thing because we don't have the room for that, but also faster than doing it by hand, so we had to come up with some like solution that's an in-between that also would fit in the small space of our brewery.
Yeah, the reason being that with the whole last year, we did not see a lot of enough people coming in the tap room, so we need to figure out how do we make more packaged beer so people could come in and take the cans to go and make it a little more simpler, but also giving a good quality of beer. There wasn't a canner on the market that we thought,
for us,
yeah.
So we basically said screw it and came up with our own.
Most of the smaller ones are, when you look at a commercial canning line, are upwards of $50,000. So we just designed a small 4-head filler that will do the same thing as some of the larger canning lines, obviously with a little bit more labor, and we had to figure out a little bit of the simplicity of it.
Where could we automate stuff and where does it still have to be done by hand? And I think kind of came up with a pretty good solution.
And keeping the consistency with the fill rates. And then another thing we had to do is we had to figure out how to purge the can with CO2 because that's very important so we don't oxidize the product. Anytime you put liquid into a vessel and it splashes up, you run the risk of obviously stirring up the oxygen in the air back into the liquid, and that's necessarily bad for any sort of, especially beer, but other products as well.
Mm-hmm. So we knew somehow CO2 to purge it, fill the beer, pneumatics to bring the fill heads up and down, multiple timers, one for the CO2, one for the beer, emergency stop button, and a regular start button.
And a purge, I think that was after the fact. I decided we needed a clean.
Oh yeah, the little lever knob that basically
it'll open up everything else. So
that
yeah.
is actually very useful, and I used that last day to clean out the line. Flip a switch, run water through it, and it cleans the whole system. So for the design process to come up with that, we kind of knew what we wanted to do, and we started to put a parts list together and get things, ball joints, or not joints, ball valves, pneumatics, relays, timers, buttons, and like a enclosure to put everything in. So we started laying it out. Originally we had the ball valves put in cardboard just to make sure everything's spaced out right and get the measurements. Then took some flat sheet metal, bent all of that into place, and made the little top enclosure for it. And then after that, made sure the internal wiring stuff was all working. If you want to talk about how you got the relays to open and close the ball valves,
Yeah, one of the problems, I don't know how to program a Raspberry Pi and didn't want any of that circuitry in this thing because I didn't think we needed that complexity, but we needed to figure out how a relay's obviously just low power turning on higher power circuit. So turning on the solenoids for the CO2, not a big deal. Turning on the solenoid for the up movement of the cylinder and the down movement of the cylinder, not a big deal. Those are just simple. But one of the problems that we ran into is the particular ball valve we use, and we needed to use something that was 100% stainless because it has to be food grade and be able to be cleaned with high temperature water, deal with chemicals, and deal with make sure it's safe.
So you use a specific grade of stainless steel.
So this particular valve does, but it's a rotary motor that similar works like, I guess it would say, like your electric window, that it reverses polarity to open the valve and then to close the
So
valves.
it goes
So,
one way, it would
yeah.
roll up, and then you switch the polarity, and then would roll the window down. So he kind of based that circuit off and made it out of relays. Like I said, I kind of can understand the timers, and this one signal goes to another, but with the relays, I tried figuring it out and poking and prodding at it, but I still even never.
Yeah, once you figure, I mean, it's just two switches. You just turn them off and on, up and down, so it just switches. But the wiring is a little tricky. If it's a similar circuitry to like an electric door lock, or the
Window motor.
or
It rolls it up, or rolls it
yeah,
down, or-
but the window motor's got an up and down switch too. Anyways, they're similar, but anyway, we ended up using two 12-volt car relays. I mean, they're used in almost every automotive since, I don't know, the early 70s. But they're great, they're cheap, they're durable, and if something goes wrong, you can just replace them. There's not, and the lifespan's fairly good, especially for the amount of amperage and we're pulling on them, which isn't that much.
And I was trying to sit there and think, okay, could I use a Raspberry Pi in here and somehow not need any of these circuits, or could I, say, take the timers out and put something in? And I couldn't think of a way of making it simpler. For the price of all the parts, it seemed like the best option. Trying to add like a Raspberry Pi and get all that wired up.
Yeah, and I don't even know what the price would be to do the Raspberry Pi, and so the relays are, I think we bought 4 of them for $5 or
yeah,
10, so they're not that much.
That'd probably be
Yeah, and the timers are what, $20 a piece?
like a Raspberry Pi
So-
by itself is probably like $20, $50 depending on the model you get. But
And then you're gonna need
you need the screen for the timer, you need the buttons for it, you need the wire, you need the somehow to up the voltage, because what we're running is 12 volts, but the Raspberry Pi can only do 3 or 5.
so
So
the
you
circuitry
need
would be more.
another power supply, which we already needed one in the first place. So it just seemed like the Raspberry Pi idea would have just made it more complicated, and we just still had a simple way that worked. So we felt it wasn't needed.
And for the components, I mean, this thing's, it's bulletproof, it works great, and we just order an extra part, and I don't know if we've,
Nothing's really gone out except the emergency stop button, the actual thing I
and that was
pushed
probably
in.
user error. I probably installed it, or it was kind of weird to install it, so it might have been an issue with
It wasn't really the emergency stop, it's just the on-off
Off button,
switch,
yeah.
really. We just had a big fancy red button for it.
But between the relays, the timers, there's not much else, and the solenoids for the air control valves, which is, you know,
That was probably
yeah.
the hardest part to get figuring out how to work. But once we did, it just does. Like how long have we been kind of using this for? A few months?
We've probably ran 20,000 cans through it.
Yeah. And the only issue I've had with it is the button gets a little bit of beer in it and kind of sticks. Run some water through and just spam the button until it gets unstuck.
And the button's usually a video game button, so
Yeah.
we can use a better
Arcade button.
It was one of those. We could use a waterproof button that would do that. That's using the wrong part for the application, but it works. It was all supposed to be temporary.
Plus, it was kind of fun having a little arcade button to press. I thought it was funny.
Yeah, make one that lights up.
Mm-hmm.
Other than what's nice about the machine that got put together was that the timers are variable, the fill rate's variable. So depending on
If the beer's thicker, you can up the fill rate. If there's not enough CO2 to push it through, up it. If it's running a little bit fast, you can drop the timer down. So it's super easy to adjust and get it dialed in so you'll lose the least amount of beer due to spillover. So it just works. Part sourcing?
So as you saw the finished product kind of work with filling the pint glasses. We normally fill cans, but that gives you a good visual presentation of
Shows
like
actually
fill, rate, and we already have plans for version, I don't know,
2.5, 2.0.
2.0, but I don't know if it's officially enough changes to call it a 2.0, so maybe we'll call it 1.75,
Mm-hmm.
6, just to
I don't know.
screw with somebody. Anyways,
1.6.
so when you saw that last video with the fill rate, there you see that little bit of foam.
the motorized ball valves are set with 12 volts. Those things are adjustable from 9 volts to 24 volts. So we're gonna try an adjustable power supply that can maybe get up to the 24 volts to see if we can speed up the opening and shut rates of the ball valves
Even just by a little bit could help.
to knock down maybe a quarter inch or half inch of foam so you get the fill rate. So if we can keep the foam down, that's more liquid.
It's as the ball valve starts to open, it's that tiny little opening that the beer has to spray through, and that outgasses the CO2 and it gets out of solution, starts foaming.
Yeah.
So the first initial set of beer, a little bit of foamy, doesn't matter, the rest will fill it and push it out. But then the last bit of foam as it closes is the most annoying part, because you could have a perfect can that's ready to be seamed, and then as that thing starts closing, it sprays a little bit of high pressure beer down there, foams the whole thing up, and now you're down a little bit of beer which looked fine beforehand.
Yeah, so that's just one of the small, it's not bad, but
Minor thing that we want to change for the next iteration.
we know it could be better, so we're gonna try to move forward and be in on that. So about, I don't know if we mentioned in this video, and when you're building a project like this, I think, I don't know for me, but it's, as you see this too, that you see that 50% of your time is like part sourcing. You're trying to design, you have this puzzle in your mind of how everything's supposed to fit together and what parts you need to make it work, and then so you source and you look, and
Trying to find
Amazon's good for a lot of that stuff, the simple stuff like the hoses and connectors that we get from them. But
the
a
more
lot of the
specialty
specialty stuff we have to get from other sources, like McMaster and all those other ones, and Granger and more of the industrial websites. You spend a lot of time looking for stuff, and it's kind of like a puzzle, because you get all the pieces and it's like, okay, this one's going to fit, this is going to fit, this is going to fit, and then the last one doesn't work.
And then you have to look back at all.
So
of the
then
stuff
maybe
and
you
try
got to go get a bunch of other puzzle pieces to make your idea fit, or maybe call in somebody else, or call it,
Yeah.
and maybe
If you know someone who's worked on something similar, has got more
you have an idea
experience.
of a certain part that you need, and you don't know where to find it. Maybe somebody does, so that's why it's good to be able to reach out. And we didn't really talk about it much, but he's got one of the 3D printers, and those things are amazing. When I was a kid, like I didn't. There's no way I could. I had to get a file and a grinder to make whatever I wanted to.
And I can spend an afternoon making something
Precise.
loaded up on the
So,
3D printer.
The one-offs on those
Go to
are nice.
bed and wake up with a little either toy or thing I modeled, or like actual CAD design part for something that actually works.
For a part, if we need a
Yeah.
button or a switch, and he can 3D print that, and it's pretty amazing. So,
Got that for my birthday a couple years ago, and taught myself 3D modeling, and really enjoyed it. It's been a lot of fun.
so I hope you enjoyed the presentation. And anyways,
I had fun doing these 3 projects, and this one was kind of an excuse to upgrade the system. Like I said, we've worked on this previously, but we had about a week to plan all this out and make the 2.5, 2.6. But
that was 1.75.
1 point. Okay.
Jeez, I have no idea.
1.2 over 3. Yeah, but didn't quite get it done in a week. Most of the parts are here, but not all. So, figured just talk about the design process and the prototype one, and get the video out.
Yeah.
So, hope you enjoyed.
Enjoy. Happy canning.